Hi, welcome to Dawit Academy, where you can access informational and educational videos that will help enhance your performance in high school, college, and university. In today's video, I wanted to go over um, the concept of calculating the exact value of the instantaneous rate of change. This is mainly pre-calculus work, introductory calculus, getting you into a concept of the derivative, which will come later on in Calc 1. But basically, if you've been following our previous videos, we've been talking about calculating the instantaneous rate of change, or how a parameter changes at an instant and moment, or how we're calculating the change of one variable with respect to another on a function at a particular instant in time, or on a specific value. And we were going over the different methods of calculating an estimate of this instantaneous rate of change. So the issue that we encountered was we really can't find the slope of a point, right? Even though we're trying to calculate the slope of the tangent, if that tangent line is passing through one point, you can't really get from that one point the slope. You can't calculate. You need 2 points. So we were using different methods to get an estimate of the instantaneous rate of change. So in this video, we wanted to go over how to calculate the exact form or exact value of the instantaneous rate of change using the difference quotient. So I'll be going over the difference quotient with you. We'll be going over 2 methods. The first method is to find the exact value for the IRC at a particular given x value or given point. And the second method would be like the delta process, where we use limits to determine the function or an equation for the instantaneous rate of change, where we can then use that equation to calculate the instantaneous rate of change across any point on the given function. Just before I continue, again, I thank you for coming to my channel. If you would like to please subscribe, click the link below and give it a thumbs up, share it with your friends. If you enjoy our videos, we're going to be pulling out more and more videos pertaining. I'm trying to go through the calculus curriculum according to the Ontario curriculum here in Canada, but I would like to also get into more university material in calculus very soon. So I'm going to be going over the calculus and vectors curriculum, which is described by the Ontario Ministry of Education here in Ontario. But then afterwards, I'll be going over Calc 1 material from university and eventually Calc 2. So let's get right to it. So what we have given for us a function f of x equals x plus 2. So the characteristics of this function, as you know, it's a degree of 1, so it is a linear function, has no leading coefficient, and it has a y-intercept of 2. So we can quickly draw this, right? We can draw the linear function. And the easiest way I would say is to find the x and y intercepts. So we'll look first at our x-intercept of the function. So we set y equal to 0. So you have 0 equals x plus 2. And the x-intercept would be x equals negative 2. So we just, again, we're drawing a sketch here. So that's our first point, is the x-intercept negative 2 comma 0. And then we're going to find the y-intercept. So the y-intercept, we have to set x equal to 0 to solve for the y-intercept. And so basically we look for y equals 0 plus 2. And if you know the y equals mx plus b formula, which you probably are very familiar with now from your previous high school years, your y-intercept now is 0 comma 2. So pass through here. Okay, so now I'm going to draw a line that passes through this these 2 points. So this is 0, 2. Draw a line. There we go. And we use a different color, I guess. And pass the line through these 2 points. So this is approximate line, a linear or line that passes through these 2 points. And now we can, because it's a linear function, we can readily calculate the instantaneous rate of change because we know it's constant throughout the function. But my goal here is to use the linear function to calculate the instantaneous rate of change using a method called the difference quotient. Now, the difference quotient states this. Let's say we want to find the instantaneous rate of change when x equals to 4. So let's say we want to find when x equals 4, what is the IRC? When x equals to 4. So let's find 4, and according to the function, let's find f of 4. So f of 4 would equal 4 plus 2 is 6. So our coordinate would be 4, 6 on our linear function. So we find 4, 6. So this would be approximately 4, 6. I'll just change the color there. Great. So that's my 4, 6. I'm just going to draw a dashed line connecting from the x-axis and then connecting to the y-axis. So the issue we see here is, again, we have 1 point and we want to calculate the slope of the tangent across to that point. We know it's a linear function and we don't have another point. We only have that 1 point, 4, 6. So what in the difference quotient, what we're trying to do is we're going to choose a point very close to 4, 6, but we're not actually going to give it any sort of number, right? We're not just going up by 0.01. We're not increasing it by 0.01 or 0.001. We're not going to go that route of the right-handed limit or preceding following. We're trying to get an exact value. So what we're going to do is we're going to choose a point very close to 4, 6. And that point we're going to call it x, y. Just, we'll call it x1 and then y1. So we're going to call it x1, y1. And if we notice that point, because it's not really, we don't have a defined value for x1, y1, we can assume that point, if we wanted to change it and bring it very close to the point of interest, which is 4, 6 in this case, that as we approach 4, 6, we can see that the difference in terms of the x component and the y components is becoming smaller and smaller. So what we can do is maybe look at a different color. So as I bring this closer and closer, this is the initial value. This is my initial x1 in orange. And this is my initial y1. Again, in orange here on the y-axis. So as we bring that point closer and closer, what's happening is we're closing this gap. Okay, this gap is becoming smaller and smaller. So we can look at this distance, and the difference between the difference between the gap on the x-axis, we're going to call that distance h. Sorry. So we're going to call this h. Now, what does h represent? H represents the distance between x1 and the x coordinate of the point of interest. So if we look at x1 minus 4, we're going to call this h. Okay? Now, this difference is what we're trying to make it equivalent to a value, which as the gap gets smaller and smaller, we're getting h approaching a certain value, which is approaching 0. So if you notice that gap over like some, as we bring it closer and closer, this gap is becoming smaller and smaller. So that difference h is becoming closer to 0, okay? So as we bring this point, any arbitrary point on this function, as we bring it closer and closer to 4, 6, this gap on the x, between the two x coordinates of the point of interest and the arbitrary point that we're using, x1, y1, it's getting smaller and smaller, and we're going to call this h, okay? So now let's calculate the slope between these 2 points. One is an arbitrary value, x1, y1, and the other point of interest we know. So let's find the slope. I'm just going to draw that here. And we follow the formula. So it's y2 minus y1 over x2 minus x1. So y2 in this case, we use the far right point to the far to the furthest of the point of interest. So we have y1 minus 6 over x1 minus 4. So this is our point. This is the slope value that we were trying to calculate. And the goal is we want to find what is the instantaneous rate of change at 4, 6. Now, if I substitute 4 directly, so as we mentioned, if we put in 4 directly, what's going to happen is we're going to have some trouble here because we're going to end up with 0 in the denominator. And we know 0 in the denominator is undefined. We're trying to avoid that setup of getting the exact value that we want, the point of interest, because we know that we can't find the slope across one point. So what we're going to do next is, so the arbitrary value that we chose, x1, y1, we can represent this in terms of h. So if you look at 4, 6, the distance between 4, 6 and x1, y1 on the x-axis is h. So I can represent x1 as being 4 plus h. So I'll just put that here, x1 equals 4 plus h. And therefore, y1 would be represented by f of 4 plus h. So this y1, instead of writing x1, y1, x1 we can represent it as 4 plus h in terms of the x coordinates. And y1 we can write it as f of 4 plus h. So now instead of using x1, y1, we're going to use 4 plus h comma f of 4 plus h into our formula. So I'll just clear some space here. So we're going to write out our formula again in terms of the slope of the line, which is y1 minus 6 over x1 minus 4. And instead of x1 and y1, we're going to represent f of 4 plus h. So f of 4 plus h. And the 6 came because we solved for f of 4. So this would be minus f of 4. That's the y coordinate of the point of interest. Over over x1, which is 4 plus h, minus the x coordinate of the point of interest is 4. So now we can see that the 4's cancel in the denominator, and what's left is f of 4 plus h minus f of 4 all over h. Okay, now we're trying to close that gap where h becomes closer and closer to 0. So we're using something called the limit, where h gets close to 0. It's almost going to become 0. So the goal here is if I substitute 0 in for h now, the denominator is going to have a 0 in it, and that would create an undefined situation. So instead of doing that, if we can find a way in the process to eliminate the h through substitution or through simplifying the expressions, then we can further elaborate by subbing in h equals 0 because we already eliminated h from the denominator. So right now at this point, I can't sub in h equals 0 because that would give me an undefined situation. But let's solve for f of 4 plus h. So what is f of 4 plus h? What that means is we want to write our function in terms of 4 plus h. So wherever we see an x in the function, instead of writing x, we're going to write 4 plus h. So let's do that. So that would give me f of 4 plus h would be 4 plus h plus 2. And then minus f of 4. We solved for f of 4 already. It's 6. So minus 6 over h. And what happens now is we're going to simplify the expression. So 4 plus 2 is 6. Plus h minus 6 all over h. 6 minus 6 is 0. So you end up with h over h. H is canceled, and what's left then is 1. So this would give us the slope of the tangent, or the instantaneous rate of change at that particular point, 4 comma 6. The slope is 1. Now, this is a long method. We know it's linear, so really the slope of a line is constant across the whole line. So you could have just chosen any 2 points, including the point of interest, and you would have got the equivalent slope. But in this case, what we're trying to use is a simpler equation to elaborate the difference quotient. As you notice, the difference quotient means we take the point of interest, and from the point of interest, we choose an arbitrary point along that function, close to it. We assume it's close to it. And we call it x1, y1, or x prime, y prime. Then we start closing that gap. So we look at that difference in terms of the x coordinates as h. We're trying to close that gap where that arbitrary point gets closer and closer to the point of interest, where h becomes close to 0. So when we use that gap in terms of h, then we end up generating, as you saw here, f of 4 plus h, or f of the x coordinate of the point of interest plus h minus f of the x coordinate over h. So if I wanted to write this as somewhat as a function, or as an equation, let's say, instead of not really a function, but as an equation, what we end up generating is a simple formula that we can use to calculate the instantaneous rate of change using the difference quotient. And we call this formula f of a plus h minus f of a all over h, where a is the x coordinate of the point of interest. I'll just write that here, where a is the x coordinate of the point of interest, so where we want to find the IRC. All right, so let's go over another example, but with a different function. Okay, so with a different function, and a lot of times you don't even need to draw out the function, but it's good just to visualize. And it helps as well to identify some key points and parameters in your function. So it's a good habit, but it's not always necessary. So now, we'll keep this formula up here, and I'll just move it. And we're going to start off with another function. Let's assume our function is f of x equals x squared plus 4. Let's say, yeah, so x squared plus 4. So here we know it's a quadratic function. It has no leading coefficient, so it follows the 1, 3, 5 step pattern. And the vertex is at 0, and it has a vertical shift of 4 units up. So the vertex would be at 0, 4. So if we sketch this quickly, there's a quick sketch. If this here represents 4, it's a parabola opening up, and it follows the 1, 3, 5 step pattern. So if you move over 1 to the right, it's going to go up by 1. So if this is 4, 0, sorry, 0, comma 4, then the next point, if you move 1 to the right, would be 1, comma 5. And another one over to the left would be negative 1, comma 5. That's your vertex. All right, so now this is your parabola. Looks something like this. It's a quick sketch. And let's say we want to find the instantaneous rate of change when x equals 20, let's say 25. Let's assume we want to find a instantaneous rate of change at x equals 25. So it would be really burdensome to sketch this parabola where x equals 25, draw the line and calculate the estimate using the preceding following method or using a graphical method, but we're going to use the difference quotient to get the exact value. So we're going to follow the formula f of a plus h minus f of a over h, where a is the x value of the point of interest. So you want to find the IRC when x equals to 25. So let's change this and let's go right to the equation. So f of 25 plus h minus f of 25 over h. Now, f of 25 plus h means you go to your function, anywhere you see 25, anywhere you see an x variable, you're going to substitute 25 plus h into it. So let's do that. It's just x squared plus 4, so you'd end up with 25 plus h squared, all of that squared, minus f of 25, so open parentheses, or brackets, I'll open brackets here. So it's a minus f of 25, so 25 squared plus 4. And all of this is over h. Okay. So far so good. We just subbed in the formula f of a plus h minus f of a over h, where a represents the x coordinate of the point of interest. In this case, we want to find the instantaneous rate of change at x equals 25. So here we simplify. So we have a binomial squared, perfect square binomial. So the pattern is 25 squared plus 2 times 25 times h is 50h plus h squared. Now you could easily use distributive property or FOIL, right? 25 plus h times 25 plus h without using the brackets or arrows to use the FOIL method. But if you know that's a binomial squared, you can follow the pattern a squared plus b squared. So a squared plus 2ab plus b squared, and that's the formula for a binomial, perfect square binomial. So we have 25 squared plus 50h plus h squared minus 25 squared. And then this negative can distribute. So the negative distributes to the 25 squared, and the negative also distributes to the 4, which is minus 4. Let's just simplify, rewrite this quickly. So we got 5. And this is all over h. So off the bat here, I can simplify. I can see what I can simplify. There's some common terms that can get canceled. So we have 25 squared minus 25 squared. So even if it was like a large number, you don't really need to calculate it on the calculator. You can simplify it right now. 25 squared minus 25 squared is 625 minus 625. And that leaves you with 0 in terms of the 25 squared gets canceled out. What's left, there's nothing else in common, so what's left is 50h plus h squared minus 4. So I'll just rewrite that. So 50h plus h squared minus 4 all over h. And So we forgot. So I'm going to review that I just missed. So at this point, we substituted f of a plus h minus f of a over h by replacing a with the x value of the point of interest. In this case, we want to determine the instantaneous rate of change when a equals 25, at x equals 25. So that's our a value. So we sub it into the formula. We have f of 25 plus h minus f of 25 over h. So if we remember, f of 25 plus h means we're going to take 25 plus h and sub it into the given function wherever we see an x value. So 25 plus h gets substituted into the formula. So it would be 25 plus h squared plus 4 minus f of 25. So I'm going to open brackets, and I'm going to substitute 25 for x. So 25 squared plus 4. So this is also plus 4 here, all over h. So now we're going to simplify the 25 plus h in parentheses squared. If you remember, this is a binomial square, perfect square binomial. And that follows a simple pattern. So the pattern for that is a plus b squared equals a squared plus 2ab plus b squared. If you forget this formula, or this general rule, you can use FOIL. So you can write 25 plus h times 25 plus h, and you start using the arrows. So first, outer, inner, last, so FOIL. That's a little bit tedious. If you follow this formula or you remember it, it is much quicker to solve the binomials, perfect square binomials. So you end up with 25 squared plus 2 times 25 plus h times h is 50h plus h squared plus 4. And now I'm going to distribute the negative into the brackets. So if you remember, the negative is outside of the brackets, and there's 2 terms in the brackets. So we have 25 squared plus 4. So we distribute the negative across each of the terms in the brackets. So negative 25 squared minus 4. And all of that's over h. So at this point, we can simplify. So if you notice this 25 squared, we know it's 625, but we can keep it that way because 25 squared is subtracting with 25 squared. That would give you 0. So we're simplifying the expression in the numerator. 25 squared and 25 squared cancel. 4 minus 4 is 0, becomes 0. And what's left then for us is 50h plus h squared all over h. And if you remember, the goal here is to try to eliminate h in the denominator. At this point, we're trying to substitute h as 0, but I can't do that now or earlier because you would end up with 0 in the denominator, which is undefined. So as we bring this gap and we're trying to get it closer and closer, we need to eventually substitute h equals 0. But to do that, we need to cancel it from the denominator so that we get rid of that undefined situation where you have 0 in the denominator. So what we're going to do next is we're going to see how can we cancel out h. What would be necessary here? Is there anything we can do to cancel? Well, let's take a look. So if you notice, you have 50h plus h squared over h. So there's a greatest common factor that we can factor up from the numerator, and that's an h. The h term can be factored up. So you have h, and then now you open parentheses, and what would be left? Well, we can easily determine that. That's 50h. We're factoring out an h, so if you want to remember this rule, it's very simple, it's very helpful, so that you can keep track of the work and you don't really do any calculation errors. You take 50h and you divide it by h. So that will tell you, or that will determine what's going to be left in the parentheses. So 50h divided by h is 50. So we're going to put 50 now here. And then plus h squared, well, plus, we factored out an h, so h squared divided by h is just h. And all over h. Now I reached to a point that we can cancel out h. We have h as a factor in the numerator being multiplied with 50 plus h. And in the denominator, we have h. So h divided by h gives you 1. So we successfully canceled out the h in the denominator, and that's what we want to do. Once we reach that point where we don't have the ambiguity or the undefined situation of h equals 0 in the denominator, now we can go ahead and substitute h equals 0 as what we're trying to do here is closing that gap between the point of interest and that arbitrary point x prime, y prime. We get very close to the point of interest. So you end up with 50 plus h. So 50 plus h is what we have. And now we can substitute h equals 0. So we apply the limit. H approaches 0 and we substitute it. So we end up with 50 plus 0, which equals 50. So the instantaneous rate of change at x equals 25 is 50. So you can make that statement. Therefore, IRC equals 50. Where the point of interest would be, let's say point A, x is 25, and then the y coordinate would be 25 squared, 625 plus 4, 629. It's 25 comma 629. So the instantaneous rate of change, or the slope of the tangent across that point, is 50, okay, based on this calculation. So just to recap, we went over how to calculate the exact value of the instantaneous rate of change using the difference quotient, and when a point is given to us. So point of interest at this point would be, what we're trying to find the IRC is at x equals 25. And we follow the difference quotient based on the fact that the point of interest and an arbitrary point from a distance, x prime, y prime, gets very, very close. So we start to decrease the gap between the 2 points, where that difference in the x coordinate becomes closer and closer to 0. So we call that difference h. And then from there, we generated a formula, f of a plus h minus f of a over h. Where did that come from? Basically, the slope equation, y2 minus y1 over x2 minus x1. Now, y2 minus y2 is x1 plus h, and y1 is just f of x, all over h. H is that difference, that gap in terms of the x coordinates between the point of interest and the arbitrary point that we're choosing. So you end up with a formula f of a plus h minus f of a over h, and we substitute the x value of where we want to find the IRC into the equation for a. By doing so, we generate an equation, and we start to calculate for the instantaneous rate of change. So wherever we see 25 plus h, we sub it in for x, and f of 25, we sub in 25 for x. You end up with a perfect square binomial. You evaluate it, and on this side where it's a negative f of 25, just try to remember always put brackets, because that negative distributes with every term if you need to simplify further. For this question, it's not a very complicated polynomial. It's a quadratic shifted up 4 units. But in other questions, it could be a cubic, quartic, quintic function, a rational polynomial. So it can get really complicated. Always try to keep organizing your work and making it systematic. The negative goes and you open up the parentheses, and that negative distributes to every term after you simplify for f of a. After simplifying, we end up generating 50h plus h squared over h, and the goal here is to cancel h in the denominator. Once you cancel that h in the denominator and you don't have that undefined situation by subbing in h equals 0, then you're okay. You can easily get the IRC and an exact value of the IRC. So We sub in so we cancel out h and we end up with 50 plus h. Now we don't have any h in the denominator. We can go ahead and apply the limit as h approaches 0. So again, we're closing that gap. And you end up with h is 0, so 50 plus 0 is 50. So the instantaneous rate of change at the point A, 25, 629 is 50. Okay, so in our next video, what we're going to do is we're going to cover the instantaneous rate of change using the difference quotient, but in this case, we're not going to be using an actual point. We're going to try to create an equation. From the equation, we're going to simplify it. Again, we're going to cancel h from the denominator. Once we reach that point and everything where we cancel h from the denominator, then we actually get an equation for the instantaneous rate of change for any function. And from there, you can calculate the instantaneous rate of change at any x value. Once you have an equation, any x value given to you, you can sub it in, and you would get the instantaneous rate of change for any point along that function. So I'll be doing that in the next video. Okay, guys, so if there's any questions, please comment below. If you're really happy with this video, if you need to answer any particular questions, go ahead, send me a comment, like this video, share it with your friends. And if you also haven't subscribed to our channel, please go ahead and subscribe. I'll be putting out more videos every day or every other day. And thanks for your support. Take care and keep studying math. Keep going at it. Keep practicing. It's very important that you keep your mental skills sharp, and especially your math skills. Keep looking through the books, refreshing, going over the basics, going through more complicated problems. Even if you're at a much more advanced level, it's good to always refresh back every period to the basics, to the foundation, and never give up. Always keep trying, practicing problems. Always try different methods to come to the solution. As long as you know the basics, you're on your track to success. And good luck on your endeavors. Take care, and thanks for visiting my channel.